Hello and welcome to this Embarcadero Data University, and this session is going to be looking at addressing mobilization and the edge of IoT challenges that we face as database professionals using ER Studio and InterBase. My name is Stephen Ball and I'm a technical consultant here at Embarcadero, but I also am the product manager for InterBase. If you'd like to reach out to me directly, then please do feel free to email me, or you can catch up with me at my blog, delphiaball.co.uk, or through Twitter at delphiaball. If you are watching this live, then obviously please feel free to use the chat window as we go through, and I will be fielding questions live as we go through and at the end. So when looking to address this session, it really kind of breaks down to a few different things, and I'm going to try and use some live stories as we go through to help us explore the challenges, both those that are seen and unseen, for developers, for architects, for system administrators, and we'll see as we go through that there's a number of ways that we can face up to these challenges using very productive tools like ER Studio, Team Server, and uniquely in a way the InterBase database engine itself. So I'm going to assume that pretty much you have an understanding about what Embarcadero does as a database tools vendor. But very briefly, obviously we have a few tools that are quite applicable really to helping us get out into the IoT world. And I think the first thing is really on this side over here, the modeling and metadata tools. It's important to know what we have today because we need to be able to help model that out onto IoT, because if we don't, trying to link the information back in afterwards is going to be a nightmare. And there's some great capabilities to reverse engineer and forward engineer different databases, and working even now into NoSQL, which tends to get used quite a bit. I think there's going to be a second development rounds, the whole IoT side, mobilization side, expanding on the mobile caching of databases. We'll explore a bit of that as we go through, because, well, let's face it, if you take email as an example on a mobile, you wouldn't be able to work your email effectively if you didn't have some data stored on the mobile device itself. And we take that for granted, that we can work on the train, on the plane with our email. If you're using NoSQL, then that's not necessarily the case. You're needing that live connection. So there's going to be a growth, I think, around the resurgence around getting data and storing it on the mobile device for certain operations. And we're certainly going to explore that, especially around the business side and the high availability side of data. It is certainly quite an important factor. There's the second part here, which is to do with the optimization and change of data, which we're not probably going to cover that area too much in here. Certainly there's a bit around the development side. I think certainly the rapid SQL integration into the collaboration tools, which come out as part of Team Server, is very important from a development point. And especially when we're trying to work, taking our existing data and architecture out onto IoT, having the rapid SQL and the core Team Server there, building that bridge is very important. To get out to the developer, to have the architect linked together, to be able to have that domain knowledge and understanding, especially when we start looking at what can and can't be stored out onto mobile. It's really important that that rich information is available directly. So these are all the kind of the database tools that Embarcadero has, but Embarcadero also has its own database, and that database is InterBase. So InterBase itself is available in a couple of different versions. We have a server version, which allows one or multiple connections to it. That runs on Windows and Linux on 32 and 64-bit. It supports Ubuntu, Red Hat Enterprise 6, and also SUSE as well. So really fully featured, supports the latest versions of all those operating systems. We also have an embedded version of InterBase that you can run inside your applications that are deployed. And we have these today running out on Android, on iOS, on Mac, on Windows. Literally anywhere that you want to be able to get out to today, you can get a copy of InterBase out on those platforms. Great thing about InterBase is, it's very relevant for IoT. There's a feature called change views, which we'll talk a little bit about later on, which when we come back to the caching of data is very, very important. But InterBase allows us to do something beyond what really the only other option we have out on mobile is, and that is SQLite. InterBase is fully SQL92 compliant and beyond. SQLite doesn't provide all those features that are required to there. SQLite is either encrypted or not. It's really a flat file on steroids. InterBase provides column level encryption. It allows us to define ahead of time. It allows the architect to be involved in terms of saying, yes, this is the data structure, this is who can read what, passing it to the developers to then work. It protects all the way through the development life cycle. But that's a small bit about InterBase. I want to really just get into some stories, and we're going to explore some of the challenges as we go through thinking about existing applications, getting those mobilized, and taking them out onto the edge of IoT, using some real stories here to get our brains thinking about the challenges that we need to address and think about as a team going forward. So this is a story about Spinali Design. These guys are a French company who use Embarcadero's development tools, Delphi, and also InterBase. They have integrated sensors that track UV rays and have those connected up in a bikini that then is tracking data directly out onto a mobile application stored in an InterBase database. And as you collect the data out on the beach, you might not have connection. Certainly, if you're abroad, you don't want to be streaming information to and from a cloud storage because, hey, that's expensive. But it just collects the data, analyzes the data locally on the device. If the battery dies, you can plug it back in, get it going, and it's still got that data stored. It's important to have that data safe on the device, and that's why InterBase is used there. And it's doing a practical job. As you've been in the sun too long, it'll then alert you that you need to go put some more sun cream on, or you can set it to let your partner know it's time for them to come and apply the sun cream for you. A bit of a fun gimmick, but the connected bikini and connected towel are serving a very important job. It's a nice connected story. But away from the mobile side, InterBase is it's one of the world leaders around medical. We have a huge number of medical facilities. Everything from laboratory systems that are doing analysis of petri dishes of how bacteria is growing, all powered by InterBase, to body scanners that you go through, again powered by InterBase, to things like Management Plus and Hove Medical, who are a Norwegian based company doing something similar, where they're storing electronic health records, data that has to be properly, securely stored. And in all of these are situations where you cannot afford for data to be lost. You can't afford to tell a patient they need to come back in to go through a body scanner again. Or you can't afford when you're growing bacteria in the labs and analysing it hour by hour to work out what drug you need to give somebody to save their life. You can't afford for data to get lost. and using advanced features like the journaling with the encryption model that's there, bringing all those bits together, running these systems in a place where you really don't want to have a DBA on standby. You need database systems that get up and go if there's a power cut. You need to have very admin-free, reliant systems. These are systems right out on the edge of providing data back into the main systems of the hospital that's critical. And a lot of these systems today are running kind of a client-server setup with a server system within the lab with the devices connected in. But they're also looking more and more now to be able to go out beyond the hospital system, beyond the healthcare centres, and provide field expertise to midwives, to community staff who are going out visiting patients, collecting data, who have to take small subsets of that data out with them and then update it back later on. And that subset of data could be run in a couple of different architectural types, and I'll explore those a little bit later on. But safe to say, it's secure and ready to go. Management Plus a specific company like this. And what I want to do is I want to pretend now that we are Management Plus. We are their data architect team. We are their development team. We are now at the point that we're being challenged to go out to mobile. And let's think about some of the challenges that we need to think about right now. So we know our current domain, we know our current model of information, we know what that data is used for. It's currently stored inside our domain. First thing we need to start thinking about is what the devices we're going to be getting out to. These could be mobile devices, or it could be laptops. Laptops could be more under our control than mobile, but let's think of both. Now, traditionally, we've had things on our network. It's been controlled. It's within our domain. The devices, like our laptops, can be well secured down. We've not had many platforms to worry about. As we move out to mobile, however, we start hearing things about bring your own device or choose your own device, where there's a range of devices that you can choose from. We are starting to think about, just like mobile, email, we want to have data out on the devices that we need to keep updated, that we want to be able to work with to ensure that high up availability of data. That's going to provide us some syncing stuff that we need to worry about later on, but let's park that. From a development, from an architectural point, we've got, and from a system administration point, we've got devices now that are going to be actually set outside the domain. These devices may not actually be owned by us. We're going to have data out on these devices that we need to keep secure. We need to ensure the encryption and security of that data. We need to ensure that the data is adhering to our data definitions about who can see what. We've also got many more platforms that we're not particularly used to dealing with out on mobile. And mobile is a big part of the IoT infrastructure. There's also embedded devices, and again, these are different from the traditional database server platforms. So we could be looking at using cloud storage. We could be looking at using data that is a mix of cloud storage and data on device. We could be looking at using our own built middle tier that allows us to have a single sign-on to collect the data, to sync with the data, to do our work. And this is quite a common approach now, especially as we're wanting to tap in using Bluetooth and Wi-Fi to devices and elements around the edge. If it's a Fitbit or if it's a watch, if it's a bit like the bikinis, some specific sensors. It could be beacons, that were being used to help identify where we're at. All of this linking back together is really where IoT for Enterprise is going. But let's just keep a focus just on the data. We know these devices are required for connecting to these different things and collecting the data. but the safe storage of the data, the caching of that data that we're required to either take out and bring back, how can we best manage that? Well, let's think about what we should be doing today. Everybody should be managing their own data dictionary. So one of the best ways to be able to do that is to use something like Team Server. And in there we can define our data types, we can define what size they should be, we can use the tribal knowledge, getting people to input into the portals, what type of data should be in there, what the values that are allowed to be stored, if it should be encrypted, who should have visibility of this data, if there's any regulatory information that we need to know about the usage of that data. If it's credit card numbers, well, it should have its own encryption key if it's being stored on a device, if you're collecting that information out on a field, for example, and bringing that back into process later on. I've worked on systems that have been literally running in the middle of a golf club, POS tills out in the middle of a golf course where they've been collecting and taking credit card details, then bringing that back in and having it processed through at that point. On those devices, you need to have a unique encryption key ready for the credit card details. So there's lots of information that we need to be storing in that we need to have identifiable. Now that's great getting it in there. It's great that the data architects are able to see that information when they're building the sub-model of what they want to go out to mobile. Certainly I'd say one of the big common things here is let's think about what data we do need to take to mobile. We don't want to take everything. Let's use something like ER Studio to define out a sub-model of what we do want to take. Then let's use the portal to be able to work out the implications for taking that data out to mobile. What do we need to do with the database around the encryption setup, the security setup of it? This is all a good starting point for working out what we want to be able to have out on mobile to be operational. Now, one of the challenges really getting out onto mobile is about the databases that are out there. And let's imagine we're trying to get our data out now for our medical example. And we've been reading up onto devices, and a lot of people are saying, hey, well, yeah, use SQLite. There's encryption capabilities on devices that you can encrypt the data. That's great. One of the big problems here, though, is that does the developer have too much responsibility? As an architect, as a systems controller, if we're the data controller for our company, do we feel comfortable right now that all of the visibility of the data is going to be controlled by the developer? So let's look at how we can lower risk. If we can get into the database engine, the logic around who can see what, if we can put the users embedded in there that define who can see what data, and we can have a specific logon to define and manage the encryption policies, then we're now at the point that we can provide a database to a developer that can run a query on the database and they can see the data they're allowed to see. They may have default values that are returned back if they shouldn't see the data. This is the kind of experience that we'd expect to have on an enterprise system in-house, but we can actually get on an embedded database. And that's really a big differential here for why InterBase is a major consideration for a lot of larger companies when they're looking to mobilize their data. Also, if that database gets moved off the device, hey, we've got the encryption in place. So let's kind of review back through some of the challenges we've faced so far. We need to limit the risk with remote data. We need it to be fast and secure. We need to have field level encryption through the product life cycle. And this protects us. I could do a whole hour on just the product life cycle side of things. And I'll have some resources at the end that are worth taking down if you want to do some more reading and more viewing on those. But protection throughout the product life cycle, having that encrypted file that can move anywhere is an important part. And also with IoT, as devices are out in the field, being able to control who can get access into the data in the visibility rules, just because it's mobile. Another example would be a HR application. Should the developer see how much everybody's earning if they have to debug an application? We also need it to be admin free. Hey, Mars is a bit too far to send a DBA. InterBase is out there. It's been used in tanks in the past because, hey, you don't want to have a DBA in a tank. It really is just an admin-free and very reliable database. Something that is cross-platform, that can reduce the testing need. We can test our security layer on the database before we actually provide it out to the development teams. This helps speed up the development, lowers the risk of a mistake via refactoring a few months down the line. Oh, we need to add some capabilities in. It's done, and unfortunately, somebody inadvertently makes a field visible. The HIV status of patients or something to everybody, which shouldn't be seen apart from a few people, for example. I don't know. It's an example here. But you can control that within the data layer. You can put that in as a data administrator before that data structure is deployed. This is something that is embeddable but can scale out, and this is this is something that Management Plus are benefiting from today. Now, there's also one additional challenge, and that is really around keeping data updated. Now, I want to share another story with you, and this is to do with again, it's a medical related one. This is a pharmacy chain. Now, this pharmacy chain had 30,000 pharmacies, and they needed to keep all of the pharmacies updated with key drug information. Now, that key drug information changes quite regularly. They get instructions from the drug manufacturers. If they're issuing out prescriptions at the pharmacies and they haven't got the most up-to-date drug information, they could put in the wrong information on the bottles. So this chain, 30,000 pharmacies with around about a 250, 300 meg database that had to be updated every week. We're talking terabytes of information here that are having to get pushed around just to replace that drug information down at the pharmacies. And a big part of it wasn't changing. Why? Because it was beyond the scale that traditional replication could manage. It's costing thousands and thousands of dollars a month on the data movement alone. Keeping data briefcased and up to date is really, really hard. Traditionally with briefcasing, let's say we've got some data and we then get the first cut of it, bang, we're ready. Now, as time moves on, some data changes. And what do we need to do now? We need to update the remote data again. So we need some way of tracking or just re-pulling down the whole data set. And again, something else changes. And again, we have to update the data. Now, typically here, if we use just fetch it all data approach, this single example here, we've got 23 packets of data. And even over time here, we can see that this second field or record has never changed. Now that could be a photo. The rest of this could be just a few characters. But every time this large bit of data is having to be moved, moving data is money. So what if we could get it just to this? What if we could just move what's changed over time? Now, week by week, in a pharmacy example here, instead of moving all the data, we're moving a lot less data each time. We're dramatically removing and reducing down the amount of data that has to move. Now, we'll come back to the pharmacy example in a moment, but this here is what Change Views does. Change Views increases the app speed and performance and usability by eradicating duplicate data traffic and unneeded data costs. each device is able to get a unique fingerprint on the central data, or it could be on its own local data, and you could have subscribers wanting to know about the data that's changed here. It could just be one subscriber, which is back to the central database. Or in the terms of IoT, you could have multiple subscribers to a sensor that's out on the field, and then each of those could be picking up the local data, working with that, rather than having to stream all the data back to a central store that's then having to be streamed back out. Change views really is now revolutionising the way that you can actually put data out on the edge of IoT. It has no impact on the database speed. There's no log tables involved here. It has field level granularity. There's no triggers that you need to set up, which is quite common with traditional replication setups. There's no timestamp fields that need to be added to your metadata that bloat out the database. There's no table locking if you've got multiple writes going on. It uses an ACID compliant way of actually knowing what's going on. So even if I'm updating 1 million records and somebody else makes a change halfway through my updates, I'll find out about that later on. We don't need to lock the tables to worry about that kind of happening. Which means we have exceptionally high scalability. So let's think back to our pharmacy with our 30,000 sites that we need to keep updated. You know, this is beyond traditional replication kind of setups, really. What they have here now is they've implemented for their proof of concept, they've implemented an InterBase database that sits alongside their existing central database. It's literally on the same machine. They could put it on a separate machine, but literally it's just right there. And this has a process. There's change views set up in here that we basically read and do a manual field by field level comparison on the database that's being updated by all their current systems that updates the InterBase database on the specific tables that we need to care about, which is the medicine data. And then every single pharmacy, there's literally thousands of them, are able to subscribe to this medicine database. And then the InterBase database here is then controlling, oh, your pharmacy 1, here's your snapshot of the data that's changed. Here's pharmacy 2, oh, here's your snapshot of the data that's changed. It all handles this through standard SQL. You can actually use SQL here to ask how much data has changed before you actually go fetch it. You can ask for only data that has changed on specific fields using SQL commands. Again, no log tables. It's one line of code to set up a subscription, which is a SQL statement. It's an additional line of SQL to grant access to that. So you can actually control who can find out about the table changes, which is something you can't do with traditional log files, because typically everybody needs to have access to the log table, unless you have multiple log tables, which is just a nonsense. So it's very secure, very, very practical from that point. Now, to do the proof of concept here, we literally were able to use the RStudio to reverse engineer the the Microsoft SQL Server database. Okay, this is a screen print from another example, but you get the idea. Using RStudio, we're able to reverse engineer, get the data into a logical model, which we're then able to forward engineer out into InterBase. So the 3 steps: take the physical data, move it into a logical model, and then forward engineer it into another physical model that we could take out onto mobile. Equally, we could take out onto Windows, as with the pharmacy example. So I just want to show you what this looks like, so you can see this in action before we wrap up. Okay, so I'm just going to open up IB Console here, which is a tool that we can use to work with some InterBase databases. Here I'm just going to open up. We're connected to our medicine database. In here we've got 3 tables. This is just a really simple example where there's some medicine data stored in here. There's some categories that the medicines belong to, and then a medicine categories. This is a very simplified version. Now we have set up a subscription. So the subscription here is just using a SQL command to create a subscription, giving it a subscription name, and then we're able to tell it tables that we want to track for inserts, updates, and deletes. We can specify all of them, or if we specify none, it will be for everything, or we can specify if we're only interested in inserts, or updates, or deletes, or a mix of all three. You can put whatever you want in there. You can also track if we had a open brackets here, we could put in specific fields that we wanted to track only, so it wouldn't track the rest of the table, just the specific fields that we're interested in. And then a description here that's just purely used for as a note in here to tell us what the subscription's for. But that subscription name is used to manage connecting to the subscription. You then just use a grant command to give access to it. So I've actually got a central data viewer here, which is just the data altogether. And we can see here the different categories and the medicines for those categories. I'm just going to minimize that because we're going to use that to update our central database. And then we're going to use pharmacy 1 and pharmacy 2 here to go fetch the changes that have been made. So we're all up to date at the moment. We can see, in fact, we just go here to this data view here. We can see here's our categories, our medicine, and our medicine categories. And I'm going to go ahead and let's go ahead and clean these up. We've got some erroneous numbers at the end, so I'll just go ahead and get rid of those. And if we go ahead now and fetch the deltas, we can see nothing's changed in this table here. In this table we have got 2 records that have been changed, and nothing changed in this table. So I'm actually going to do a show merged here, which is going to take the local data and show the deltas merged in. And here we can see we're identifying out that actually this is the fields that are specifically changed against the local data. And this is information that's provided from the server side. So I'm going to actually just let's go ahead and post these deltas in here. We can see we've updated our local data, and I'm going to go ahead and change something else here. Let's go ahead and change this to allergy rather than allergies. And we do the fetch. There's nothing changed in this table or this table, but we have got a change over here. In fact, we do the show merge. We can see that one change here. If we do the fetch deltas here, we can see that these we haven't committed these changes yet, so it's still telling us that these are available. And also there's an additional one here now. So it knows and is keeping track specifically of the changes for each destination. And it does that by, at the point we start a transaction, we then are saying set the transaction active for the subscription ID. Sorry, set the subscription active, the subscription ID name for device, and then we're passing in the device ID, which is our pharmacy ID here, and that is then using that data to track who we are and what we know about. Now, what this isn't doing, this isn't giving me an audit trail. I can't go back into the database and say, right, what was the value? All the database will tell me is what the current value is, and it's changed. Now, one thing that is quite interesting here, I'm going to post the updates in over here, and I'm going to go ahead and change this back to allergies, and I'm going to fetch the delta. Oh, sorry, I need to do that in here. And let's go ahead and fetch it, and we can see that this has been updated again. So I'm going to post that in. But if I do a fetch here, it's still showing me that this has actually changed. It shows me the record has been marked as changed. It shows me the field's been marked as changed. But it's actually just reporting back now that it's the same, but it has been changed. That's to do with the local database components, but the actual data that gets returned back is actually saying this value has been changed. So very, very powerful, actually notifying that a record has been modified, even if it has been turned back afterwards. But I'll only see one notice for it in the delta log. So even if I went and changed these records again and again and again, when I go and fetch, it'll only give me a single notification that this record's been changed. It'll give me the latest notification for it, and I can then merge that in. But it'll know if it's been an insert or if it's been an update. And if it's been inserted, it'll tell me this record's been inserted, which is pretty cool. Okay, so I think that pretty much is it for this session. I hope that's been kind of useful and thought stimulating. Really, I think one of the best ways I can advise trying to get out onto IoT and out onto mobile projects is to really think about what you need. If you need to have data offline, think about the type of data you're storing there. Team Server is a great way to be able to help manage the knowledge about that data. Using things like Rapid SQL, you can help then share that information with your development teams to make sure that they're picking up the right information, that you're using ER Studio to kind of build submodels that you can reverse engineer out and back in. We have online on the InterBase Labs page an example of doing exactly this, reverse engineering through ER Studio and then forward engineering out to InterBase, which is about a 10-minute video. So if you want to have a look at that, go to the well, if you just type interbase.com, it will redirect you to the Interbase page on the Embarcadero site, and from there you can see the Interbase Labs video tutorials, and it's one of the recent ones up there. But yeah, use ER Studio to build the subdomain with the knowledge that you've got, forward engineer that, get your data model properly encrypted before it goes anywhere. Mobile phones are now more popular for theft than handbags and wallets because of the value. And if your data's on there, the last thing you want to have to do is report that as a data breach because, hey, we all know data breaches typically cost us about 4% of our customer base. They cost a huge amount in fines and helplines and goodness knows what else. So if you're putting any data out onto mobile, make sure it's encrypted. Look at how you're going to get it out there. And then, just make sure that your data is following the business rules and that you're not compromising your business integrity just because you're getting out onto mobile. So here's some additional resources. Definitely, if you're interested in the change views, I'd recommend the white paper that I've recently done on that. That goes into depth. There's 10 different reasons why it's very different from traditional data logging techniques, and thoroughly fun read. Kind of revisit the pharmacy example through that. Also, getting data out onto mobile. If you're mobilizing enterprise data, the bottom one there is a white paper. Looks at the top 5 mistakes that people make in going out that way. We've covered a few of those through this session, but still worth a view. And for your development team, if they're looking at doing mobile development, then the middle one there is a video that talks through some of the challenges around developers getting out to mobile and some of the things they can help along the way. But I think that's it. Really now it's time for some Q&A.